Alright guys, yesterday I made a video about naming hydrocarbons and I gave you some homologuses and the names of all the hydrocarbons under them from 1 to 10. And someone said that he didn't understand, I should explain the topic. Okay, so today I'm going to be talking about hydrocarbons. What are hydrocarbons? Hydrocarbons are compounds that are made up of hydrogen and carbon. From the name you can see hydrocarbon. So that is hydrogen and carbon compounds. What are the types of hydrocarbon that we have? We have two types of hydrocarbon. We have the aliphatic hydrocarbon and the aromatic hydrocarbon. Alright, so I just summarized it on the board. So we have aliphatic and aromatic hydrocarbon. Under aliphatic, it can either be acyclic or cyclic kind of aliphatic hydrocarbon. What are acyclic hydrocarbons? These are carbons that form a kind of like either branched or chain formation between them. So if you have something like this, you can see the carbon, 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 they kind of form like a chain. So anything that looks like this is called a cyclic type of aliphatic hydrocarbon. But what if it looks like a ring? It kind of like forms a ring-like structure, something like this. So your carbon is formed like this. You can see it's not just like on a straight line again, like this one, right? It is now like in a ring-like structure. So this is known as cyclic hydrocarbon and it's under aliphatic, while aromatic hydrocarbon is always cyclic, and the simplest form of aromatic hydrocarbon is benzene. For us to understand this, let's talk about what is called homologous series. So we need to understand what homologous series is if you want to understand how to name these things. Homologous series is just like a family of carbon with the same structural formula. They have a particular structural formula. So if you're talking about this family of carbon, they have the same structural formula. You're talking about another one. So this structural formula and this structural formula is not the same. Look at it like families. You have your family, I have my family. My family, we all have the same DNA. You can trace us with the same DNA. In your own family, you have the same surname, the same DNA, but your family and my family are different. Okay, so that is the same way carbon has their own family. So the families can either be something like alkanes, alkenes, alkynes, alcohol. It can be anything. Alkanes. There are so many families, but we're going to be looking at this one first. So it's small. Let's look at the basic family. The most basic homologous series is the alkane family, which is this one. But let's talk about that now. Just like I said, the homologous series is just a family of carbon, and each of the family, just the same way in your own family, you guys have your own surname. Is that not so? Like your surname can be Ejima. Then if the first son is Ikena, that one will be Ikena Ejima, Jessica Ejima, Ebuka Ejima, and so on and so forth. Everybody in that family will have a surname of Ejima. In that same way, hydrocarbon have their surnames. You are seeing this alkane. This alkane, the surname is this ANE. If you see all of them, are you not seeing ALK? All of them have ALK. Is that not so? The only thing that is different in them is this ANE, ENE, YNE. So you look at those things as the surname of that family. So in this family, the suffix, or what I like to call the surname, is AN. In this family, the surname, or what I like to call the suffix, is ENE, and so on and so forth. So it always have a prefix and a suffix. When you put them together, you get the name of that particular carbon compound. So let's look at it. How do you determine the prefix that you use for a particular carbon compound? You determine the prefix by identifying the number of carbon atoms in that compound. Look at this example I gave, for instance, this one here, and yes, this one. How many carbon atoms can you see? You can see 3 carbon. This 1, 2, 3. Can't you see the 3 of them? That means this particular compound has 3 carbon atoms. So you note it. 3 carbon atoms. Okay? Now, for the families, they have what they call functional group. Open your ear. I said functional group. This functional group is what will let you know what is unique to each family, to each homologous series. Okay? So that is what will make you identify easily which family does like a carbon compound belongs to. Like in this one, it is either the functional group that we have, the simplest one that I wrote on the board here and I gave in the other video, is we have the single bond, the double bond, and the triple bond. There are so many other functional groups. The functional group is what is attached to the basic carbon compound. We'll talk about that one in another video. But what is attached to the basic carbon compound? So the 3 functional groups I spoke about in the other video, which we are starting with, we'll talk about other functional groups in another video, is, or rather are, single bond, double bond, and triple bond. Single bond, double bond, and triple bond. So if it is single bond, look at what I mean by single bond. Are you seeing this? C, C, C. Now, how many dash are you seeing here? 1 dash. This means this carbon and this carbon are bonded singularly. That's single bond, single bond. When you see just 1 dash, that's single bond. So if you look at this example now, all of them single bond. The carbon to carbon chain is just single bond. Do you understand it now? Good. Now, what if you had something like this? Are you seeing? Now we now have 2 dash. That means double bond. Exactly, double bond. So when you see single bond like this, because single bond is the functional group to the alkane family, right? Then you can call it alkane. So it belongs to the alkane homologous series. It's as simple as that. There is nothing attached to it. No branch, no OH, no halogen, nothing. Just carbon like this, and single bond. That is definitely alkane homologous series. What if you see something like this, nothing attached to it, but there is double bond in it? That belongs to alkane homologous series. That is how to identify which family it belongs to. So you have to look at, from the root carbon compound, what is attached to it. Is there any kind of different bond? Is there any kind of substituent? Because if you look at the bond, they also look at the substituent, whether a halogen, because it's an halogen, you have something like haloalkane and the rest of them. We'll talk about that in another video, but I'm talking about the basic homologous series attachments. So it's just single bond, double bond, and triple bond. So what if it was triple bond like this? This triple bond. So what homologous series does this belong to? That means it belongs to the alkane. I don't really know the pronunciation of it. Somebody should help me with the pronunciation. I don't know, but I just know that this is the homologous series for triple bond. So it has YNE. YNE, remember I told you it's like the surname. So prefix and suffix together will give you the carbon name or the organic compound name. So to get the suffix, you have to know the homologous series. So it is either ANE, ENE, or YNE, or any other homologous series that it belongs to. How about to know the prefix? Prefix is the word that comes before the suffix. How do you know the prefix? I told you it is by what? Counting the number of carbon chains. Now, like this one now that has 3 carbons, anyone that has 3 carbons, the prefix is always probe. Probe. So because the prefix is probe, it has 3 carbon chains and it belongs to the alkane family because of single bond. If you mix the prefix, which is, what if it has 2 carbon chains? It has 2 carbon chains and it belongs to the alkene family. What would the name now be? It's probe, and the suffix, which is the homologous series, you have the name. The name is propane. Something like this, right? And this is alkane, right? So this is alkane, definitely. Okay, so but it has 2 carbon chains. 2 carbon chains is known as eth, ETH, eth. So if you mix eth with the homologous series ENE, if you mix it, the name will now be what? Ethane. So this is just the simple way of knowing the names of carbon compounds. Let me give another one. What if it's just only one? It's not 2 carbon again or 3 carbon, just only 1 carbon. And that 1 carbon probably belongs to the alkane family. So just single bond. It's bonding singularly with hydrogen. So this is just 1 carbon. So if it's 1 carbon, the prefix is meth. If it is 2 carbon, the prefix is eth. If it is 3 carbon, the prefix is probe. If it is 4 carbon, the prefix is but. If it is 5 carbon, the prefix is pent. If it is 6 carbon, hex. 7 carbon, hept. 8 carbon, oct. 9 carbon, non. 10 carbon, det, and so on and so forth. So the prefix is fixed. It's just for you to know what homologous series. So if it is alkane, methane, like this is methane. So you see it now. So the 1 carbon is meth. If you mix it with the homologous series, it becomes methane. What if it is ENE? Methane. What if it is YNE? Meth and YNE. So meth for 1 carbon and the surname, which is the homologous series family name, whatever it is. When you mix it together, you get the name. So I'll refer you back to my previous video. Go there, you would watch what I presented there as different homologous series and the names from meth to det. Now, in summary, let's summarize what we said. We said that hydrocarbons are made up of hydrogen and carbon compounds. And I said that hydrocarbons are divided into 2, aliphatic and aromatic hydrocarbons. I said that aliphatic hydrocarbons are also divided into 2, acyclic and cyclic, okay? And acyclic is, it forms carbon to carbon chain or branches, while cyclic forms a kind of like a carbon to carbon ring, like this ogaye. Like this ogaye. Then I said aromatic hydrocarbon, they are all, the simplest form of aromatic hydrocarbon is benzene. Okay, so thank you very much for watching this video.